Yeah, so today we're talking about soil. That is what I studied. Not in my undergraduate. In my undergraduate, I was in the ocean. I was hanging out. No, it's not dirt. How dare you, Abriel? That was very rude. I did not like that. No, yes, yes, soil. It's okay. You don't know. Only us nerds know. The nerds about soil. Anyway, so I would probably start by talking about what soils are, right? Soils are porous medium that are full of life, full of nutrients, right? They're full of carbon. Very important to have carbon in your soil. All right, we need to store more carbon in the soil. Um, and also, they're what everyone gets their food from for the most part, unless you're doing like hydroponics or aquaponics or anything like that. But soil is very important. Um, and soils are different, right? Soils are very different based on climate, based on, uh, a couple factors, which we're going to get into details of a little bit. Maybe not all the details, but we're going to get into some details. What what we'll start by saying is there is a acronym that is used to describe how soils are made. It's the best acronym, the only acronym people should use when it comes to discussing how soil is made, and that is CLORT. Yes, CLORT. CLORT. Very important.
Oh my god.
Uh, so, what does that stand for? Some would ask, and I would answer: every single letter is used in this acronym.
Clark.
CLORT. Beautiful. So let's start with the beginning. Climate, which is actually the CL of the word climate. So climate is very important. Is it hot? Is it cold? Is it super dry? Is it super wet? These are all important factors when it comes to soil formation. Um, you know, Soils that are weathered, meaning lots of water, have a different holding capacity for nutrients than soils that are very dry. Um, but then there's always an in between, which is actually like what you're looking for when it comes to farming. Um, and yeah, so that's climate. That's the CL and CLORT. The O is organism, which is biological activity, worms. Do we have bacteria, funguses, right? These are all very, very important
God damn it.
to.
Yeah.
There we go. These are all very important to how a soil forms. Organisms break down, organic material into inorganic material, and that is essential for plant growth. Um, so the R the R in it stands for relief or topography, which relief is really just a topographical term, stands for slope. How much slope is there where you're finding your soil from? Is there a lot of slope? Is there no slope? Because if there is no slope, that means that things will hold, water will hold, organisms will hold. But if you're on a mountain, um, that's why you don't see soils on mountains, right? The water just runs down. It doesn't really hold onto anything. Um, the only example I can think of is in holes where you got those onions growing up in that random meadow at the top of the hill.
Shout out to Derek.
Shout out to shout out to Derek.
Our friend really likes that movie.
He loves that movie. Same with Ella. Ella loves that movie. Another friend of ours. Um,
We only have two, but it's all good.
um, and yeah, relief very important. Finally, um, finally, we have parent material. Parent material is very important. Was your soil formed from a lava? Was your soil formed from limestone? Um, you know, the parent material affects what nutrients are naturally occurring when a soil forms. Um, you know, all soils have different elements in them, um, but for the most part, you're looking at some metals: copper, zinc, um, manganese, magnesium. That's not a metal technically. iron, aluminum, right? And then you also have cations like calcium, potassium.
What is a
magnesium.
cation?
A cation is a positively charged element. And there are also anions like sulfur, and that's a negatively charged element. So sulfur, you'll generally in sulfate form, but we're not going to get into that. Then there's phosphorus, right? Boron. These are all essential elements to plant growth. And the parent material, for the most part, will drive, what exists in your soil when it is being created, as it's released from its rock form to a essentially, a clay or a silt or a sand. And the last part of that is just time. That T enclorped at the end, that T right there. Time comes for us all, some would say. You can't escape it. It's there. And it's the same with soils. Soils form through time. And those factors, clorped right there, is what kind of tells you chemically, physically, sometimes biologically, what will be in your soil, right? So let's go into a little bit of like soil naming. There is, soil naming is similar to like a biological naming system, right? We have order, we have suborder, we have great group, subgroup, and then we have family and series, right? These are all they all add description to what kind of soil you're taking your sample from, or you're growing your food in, or you're walking your dog on, right? And so these are all essential, but like we're gonna focus on just the orders today. Orders, everything else, it would get very detailed, a little too intense for maybe like what we're doing. So let's go into orders, right? So our oldest order, or sorry, I should start with the youngest. Our youngest order. Our youngest order is going to be like entosols, and these are the generation alpha. They're only hundreds of years old. Think about it logarithmically, in factors of 10. Hundreds of years old, right? They're super young. They don't have a lot going on for them. They're held back by. Wait, sorry, I'm just thinking about us now. But they're very essential. What is going on?
This is time.
Oh my! We're talking about soil orders.
Yeah, this
now.
is an old. This is.
Well, we're in generation alpha. We're in the young ones.
Yes, it's a baby.
Yeah, and the soils you find there are generally like entosols.
Oh.
And that is an order. Entosols right there. They don't have much horizon development. They're very young, only hundreds of years old, right? Hundreds of thousands. That's Generation Z. That is more of like an andesol, volcanic. That's more like andesols are volcanic, right? Lava flow is their parent material, or magma is their parent material. And you also have insectisols, which are also a semi-young soil. They're both developing. And andesols are interesting in particular because they have their own specific clay that you don't find anywhere else because they're made from lava, which is really cool. Something that you find in like only tropical areas, or again where there are volcanoes. Next would be the millennials, the Gen Y, right here, and that's the thousands to tens of thousands of years old. Yes, that's us.
Question.
Oh.
What was the volcano one?
Andesols.
Andesol. Oh, I knew that.
And those ones are like our mollisols. We got vertisols. We got alphasols. Right. That's 5 soil orders right there. And they're good. They're really good. They're doing okay. They got some nutrients in them. They have
I don't know why it's a person. I'm sorry.
Yeah, I don't know why you're, but it's okay. That's fine. And then we're gonna get to like our tens of thousands of years old, starting to get there. That's Generation X. All right, and that's like spodosols and altosols, and spodosols are generally like forest floors that are pretty acidic. Um, and then altosols are just like weathered, old. Yeah, Generation X, you know. And finally we have our hundreds of thousands to millions of years old, and that's our baby boomers. All right, um,
Huh.
they but
I'm realizing I could have just drawn a timeline.
you could have, yeah. That's fine though. And that is like those are oxasols. We got a lot of oxasols here. Um, they are very weathered, do not hold on the nutrients well. Their clay is so old and weathered it acts like sand. It doesn't really hold on the water that well. It absorbs phosphorus, so that it's not available to plants. It's kind of annoying. And let's talk about like the physical part of soil, right? Like when you feel a soil, um, you're feeling pretty much four things. You're feeling a little bit of organic matter, which is just like worms, pooping, and then you have your sand, your silt, and your clay, right? And there is a triangle that has been made, essentially a diagram that with a here in post right between us, right between our heads. I'm holding it. And that triangle describes it, based on how much sand, silt, and clay you have, what is in, what your soil is derived of texture wise. Do you have a lot of sand? Because if so, it's going to drain. It's going to drain a lot. Do you have a lot of clay? Because if so, do you know what kind of clay? Is it going to shrink? Is it going to swell? Silt is kind of like the in between, but it's really, really nutrient rich. It's releasing nutrients because it's just been weathered down from the sand size to the silt size, and so it's really nice to know, and it's really easy to tell. Actually, you can just like take a cup of water, or sorry, you can take a cup of soil and you can put it into a jar and then fill that jar with water and shake everything up, um, and everything will slowly over. You can, I mean, 3 days is probably good, but you could do a week, where it'll all slowly separate into size, into texture size. Your organic matter will float in the top. Your your sand will be on like it's the heaviest, right? So it'll probably be the bottom. But then you'll have silt and clay. And yeah, that's like it's like a pretty basic overview of like what they're made of. But let's talk about them a little bit more. So sand, like I was talking about, it drains. It just drains really quickly. It doesn't hold on the nutrients. Uh, it doesn't really. I mean, it provides aeration, which is really important, right? Because roots need air. So, um, you know, if it's raining a bunch, roots aren't going to be happy. Some plants are designed to grow in water, like heavily watered areas, right? But for the most part, a lot of crops that we grow, um, that we've essentially grown for hundreds, thousands of years, they don't like a lot of water. They need it, but they don't want to have tons and tons of it. They just want to kind of maintain soil moisture, saturation point. We'll save that. Um, when it comes to silt, that is more weathered sand, right? It's been weathered even more. It's releasing nutrients. Um, it is essential. I mean, silty clay or silty soils feel really good in your hand. They feel like flour, and when you play with them, they kind of feel like flour. And they're really nutrient rich. They're great at releasing nutrients. They are, Yeah, there are more clay types. We're gonna get into it. Um, and and yeah, it's very good to have a lot of silt. Now clay is your smallest particle size. Um, it is sticky when it's wet.
Oh.
I don't even know what
What? I'm saying this is a good one.
yeah, silt is good. Clay is also very important. Clay is essential to holding nutrients in your soil. Um, if you understand what a CEC is, or a cation
Keck.
exchange capacity, a keck, or technically it's a
Wait,
tekek.
a ticket?
Total, yeah, or technically there's like total exchange capacity. But tech, yeah, but it's important. Well, I would just go with CEC. Let's just do CEC. CEC is what holds on the nutrients, what holds onto cations, right? What holds onto calcium, what holds onto magnesium, what holds onto potassium. These are all essential for plant nutrients. Calcium in particular is super essential. You don't think about it, but a lot of leaf structures have calcium in their cells. They need them. We require a lot of potassium. Plants do too. Potassium is what moves, sugars in plants, essentially in the phloem and xylem. So it is really important to have these nutrients, and so a CEC is very essential to really healthy plant growth. So clay is important to that, and this is where we get into a little bit more of the nitty gritty of clay.
You gotta wait. It's gonna become a picture.
Okay, I believe in you. So, clays, there are essentially 4 categories of clays. That's what we're gonna talk about. That's like clay is some of the most important parts of a soil. So trust the process. I'll trust the process. So, we have 2-to-1 clays. All right, 2-to-1 clays are a tetrahedral. It's a pyramid. A pyramid with oxygen atoms at the 4 corners, and right in the center is a silica. And then go backwards. Think 3 dimensions. That's not a pyramid, but that's fine. So we have remember when you drew chemicals back in the day? Yeah, there you go. That's right. You're 3 sides.
Just wait, it'll get there. Don't worry. No.
So, and you have a layer of silica and oxygen, and then you have another layer. You have another layer of aluminum and oxygen, and then you have another layer of silica and oxygen. And those are what we call 2-to-1 clays. All right. They are essential. Yeah. They are essential for holding nutrients, and it's those flat edges of the pyramids that hold onto nutrients in soil solution. So you'll have calcium attaching to those oxygens, right? And you'll have beautiful, nicely done.
Thank you.
Yeah, and then you can put a O at each of the corners.
Okay.
Oh. And then one more. And then you have a silica right in the middle. SI.
Boop.
Yeah, there you go. Look at that. That's what a tetrahedral a tetrahedral plane will look like. And then there is an oxygen connected to 6 oxygen atoms above that.
Okay.
There's aluminum in the middle, and then 6 it is yeah. But these soils are very rich, but they also have shrink and swell. Water will get into them in between the layers. that are attaching to each other, and that'll cause the soil. Yeah, there you go. That's not bad. Yeah, and then above that is technically more. Is another layer of tetrahedral.
Okay, I got it.
You have to move that.
You got it. Keep tap.
So that is essential for holding nutrients. It creates a CEC, all those oxygen atoms on the bottom of that plane, because they'll share that oxygen will share their hydrogen atoms that are connected with other elements. They'll exchange the hydrogen. Hydrogen will pop off, calcium will jump in, magnesium will jump in, potassium will jump in. All essential cations to plant growth. The next type of upside down. The next type of and the O is the bottom of the triangle.
Stop.
The next type of clay is a 1-to-1 clay. So it's just one aluminum layer, one oxygen layer, and it's not. You don't have to draw it again. They're good. They're great soils. You can grow good food in them. They don't hold on the nutrients as well, but they also don't shrink and swell, which can be really nice. Shrinking and swelling clays are somewhat difficult to deal with, because when they get super wet, they don't let a lot of moisture to flow through. They'll hold on to water too long. I don't know why you have a calcium up
there. I thought you said calcium.
No, silica. Silica and aluminum layers. And then that's 1-to-1 clays. 1-to-1 clays are important as well, but they're more weathered than a 2-to-1 clay. There are technically 2-to-1-to-1s, but it's such a minute amount of clays, we don't need to get into it. So we'll go on to andesol clays, which are amorphic.
But what's these ones?
These are 2-to-1 clays. And then 1-to-1 clays are very similar.
Okay.
Yeah. And think about the amorphic being kind of as it sounds. It doesn't have a per se form. But what it does have, for the most part, you see it in tubes. Tubes or something like that, right? And they're not. I mean, there's silica in there, but it's more aluminum, right? You got to think about what's actually coming out of a volcano. It's metals, it's things like those. Iron, right? Iron is essential in an amorphic clay, and this is where we get to a clay that is actually affected by the pH of your soil more than a 1-to-1 or a 2-to-1 clay, because they already have. That planar part really holds the pH of water well, because hydrogen can easily exchange in for other nutrients. So there's consistent swapping, always swapping between the clay and the soil solution. And then, of course, whatever plants are requiring, they'll draw it into their roots from soil solution. And so that's why you need to add fertilizers to your soil. Amorphic clays are way more affected by pH. So the hydrogens will switch with an OH. You have to control soil pH quite a lot when it comes to soils with this kind of clay in them. Do you know what kind of charge those have? There you go. Look at that. Beautiful. Very done. Very well done. So, and the same can be said about a oxisol clay, which is really just an oxygen bound, two oxygens bound to aluminum, or two oxygens bound to iron. These are the soils that are very weathered. You'll find them in oxisols. They're called iron and aluminum oxide clays. They literally don't hold a CEC. They have an AEC, in fact. They have a positively charged surface.
It could.
Yeah. Instead of a CEC, they have an AEC, an anion exchange capacity. They absorb a lot of anions very intensely to their surface level, or their surfaces. So they'll absorb phosphorus. That's the big one. It makes it really hard to utilize phosphorus in these soils because you need to essentially fill up the whole clay with phosphorus, so that it will. It's just like a aluminum bound to three a triple bond. No, a triple bond.
One with three
to a phosphorus. Well, that's what happens when you have and it's the same with iron.
Nope, that's potassium.
Yep. But it's very. You can still grow food in them. It requires a lot more pH adjustments. Using calcium carbonate, you got to consistently raise the pH because when these soils get watered, that water it moves the calcium through it, moves nitrate through it, moves potassium through. It is harder to grow in soils that have these. Well, I don't want to say harder. There are people who are really good at it, but it is a little bit more difficult and requires a lot more math and understanding of absorption of phosphorus to aluminum or iron. So yeah, that's pretty much the different clay types. That's the basic clay that the four basic clay groups.
The people were soil people. It made sense. This is Father Time.
That is Father Time, which is important to CLORPT.
It's important for CLORPT because CLORPT stands for Climate Organic Slope Parent Time.
Yeah, sure. Climate, organism, relief, parent, material time. If there's one thing you should take away from today, it's CLORPT. It comes for us all. Oh, we got viewers. Hello. I did not realize I was about to start beatboxing for y'all. I know.